Why do we need something like virtualization? You said about abstraction, consolidation and optimization, and sharing on top of abstraction, right? So it's primarily when there is so much of traffic. I mean, so much of traffic in the sense there is way too many people trying to access something. We have a resource sharing problem. Right? We have a lot of vehicles that share a single common road, isn't it? So when we have a lot of practical difficulties in understanding, using a shared resource, that's where something like virtualization comes into place. So virtualization, the primary idea behind virtualization, so abstraction by definition, in terms of usage, sharing becomes the most important part. I think Sashi, you will have to give a lot of importance to this because you don't have an infrastructure background. Okay, so primary idea about virtualization is that what it does end of the day is that it shares. Okay, it allows sharing. So it is equal to how you do carpooling. So you can have multiple people sitting in a car, isn't it? So something like that. So what virtualization ends up doing, something that we try to achieve with cloud and virtualization. You guys talked about, yeah, you are the one, Sashi is the one who said about this, right? Wanting to elastic load balancing. So one of the ideas is that you need to make sure that you use maximum utilization of resources in a given way. You need to do more with what you have, or more with less. Okay. So what virtualization does is that it does maximum resource utilization. You will have to, push in as many people as possible in a single vehicle, isn't it? Similar to this. Virtualization does more with the same, right? And this is one simple game that fits into IT infrastructure problem than anything else. If you see it, the less amount of free space that you have in between, more that you can actually do, isn't it? So this is very similar to what we have, and this is very critical for you to understand cloud-based infrastructure as a service also, because in a three-dimensional view you can fill in the space anytime, right? That's how cloud resource scheduling algorithms work. So what virtualization eventually does is that it does more with same, okay, or it does more with less. This is another important slide that's closest to me. What does virtualization do? It's there in the kitchen. You have a lot of different jars with half full, half empty content, and when you do virtualization, it comes to something like this. Isn't it? So when I ask you guys all about what is the term that comes into your mind, okay, when we talk about virtualization, this is something that I was actually expecting. When you look at this particular site, guys, do you think of any other terminology that comes to your mind apart from what you said? I'm giving a chance to every one of you. Quickly. Atul, anything that comes? That is the reason why I put this. Sharing is, sharing is something that, Vikram said, Ramakrishna said, everyone said about sharing. No, I'm asking, if you look at this particular site, is there any other word that comes to your mind apart from whatever you said about virtualization? Let me even list out the words that you used. You said about abstraction, you said about sharing, you said consolidation, standardization, organizing things, okay, not bad.
I would say resource optimization.
Resource optimization. Whose idea is this?
Ramakrishna.
Ramakrishna. Okay, I'm still getting used to the voices and I didn't say names with it. So Ramakrishna says resource optimization is a very, very good word. But there is one more that I still am expecting. Resource optimization is very valid. Good answer. Atul is saying orchestration. What do you orchestrate in a kitchen, Atul? Orchestration is a good word, but I'm a little unclear as to how it applies to the current.
So it's like if you go for a music show, there is one guy who's making all the drums, the guitars and everything played together to form a music. That's what is happening over here. In one single plate, we are having all these components together.
But the orchestrator is not seen in the picture. That's what I'm saying. Within the context of the picture. Orchestration is absolutely right. Okay, orchestration is absolutely right. It's a very, very good usage, but might not be in the given context. Inside the picture, is there something that comes to your mind? Give it a try. That's straight away there. That's what is there.
I mean, you can have multiple flavors of components in one basket.
Fantastic. Who said this?
Ramakrishna.
It's a very, very good word, Ramakrishna. You came very close to that particular word. You said multiple flavors can be used. When we talked about it, you are the one who said standardization, right, Ramakrishna?
Yeah.
And when you do standardization, you are not worried about the actual platform.
The diversity.
That the platform by itself is standardized. So I agree with your point when you say multiple flavors can coexist. Can I use that word?
It's diversity over here.
Yeah, it's unity in diversity. But good. There is another word that's so explicit. In the recent times, different cloud providers, including Openstack, have started supporting this feature. If I can say feature.
Platform.
No, you are making it too complex. It's very, very simple. What is there in the picture is what I'm asking for. If you guys can think of it.
Are you expecting something like a self-service?
Self-service? No, not exactly. A slightly technical word. A very common word that is right there in the picture.
Parameters?
No. You are making it very complex. I'm saying it's a technical word, single word. If you have been following cloud computing news, both Amazon and OpenStack started supporting it very recently. Red Hat is doing a lot of work around supporting this. I cannot give more clues than this. Think of it. Something all of you will know for sure. What is there in the picture?
Are you talking about storage?
Virtual machine?
Make it too complex. Virtual machine support has always been there. Why should Red Hat support is only now?
Open?
No. Open is an interesting word. Okay, I really didn't expect. Who said that?
Venkat.
Well, Venkat, that's completely unexpected, wonderful answer, because I didn't realize that on the left side it's actually closed jars and the right side is open. So that really is a wonderful answer. I didn't expect something unexpected. I'll take it. I'll have to be very careful next time I put some pictures in. Open is a very, very interesting word, but unfortunately that's not what I expected, but that's a very good answer. Completely creative. Huh?
That's how I present to all the VPs, so you know.
What is a jar here? On the left side you have multiple jars, and right there you have another one. What is that? What is it?
Container.
It's a container, boss. It's as simple as that. Who said containers now?
Me, Shashi.
Container is the simplest word that I was expecting. Container is a word, isn't it? How many of you have heard of Docker?
Yeah.
Like LXC, Linux containers.
Yeah.
Not exactly LXC, but container is a word. I said you can explicitly see in the picture that everything is actually a container. The jars are containers, isn't it?
Yeah.
Now, container is a word. All of you said about standardization, right? Aren't we creating individual containers? When you said different flavors are residing, Ramakrishna, you also know that the flavors are not getting mixed with each other. Different kind of dolls that you have are inside their own container. Either they are closed or open, isn't it? So they are very clearly separated from each other. Is another form of abstraction. So you can have multiple people sharing a car. Everything is compartmentalized. That's a very, very critical component, because that leads to not just sharing, that leads to some sort of secure sharing. Right? Separation of resources, or what we call in technical terms, in security terms sometimes, as isolation of resources happen by default in virtualization.
Mm-hmm.
You create separate containers. It's not necessarily Docker. Remember, every single virtual machine is a container by itself.
Okay.
If you actually look at it. You understand that? Guys, is it clear to you?
Yeah. But Docker is majorly like application virtualization.
It's an application, right? Container. No.
Yeah.
Docker is not
Sorry, right. Application container, right.
It's an application container. A Docker is not an operating system container. Docker is an application container. Docker has only the runtimes of what an application might do, whereas a typical virtual machine has a complete virtual setup. It's an operating system that is virtual. Okay, where a Docker is more a container that only has what is necessary for the application to run.
So it's majorly for application scalability.
Yeah, primarily for application scalability and also reducing the size of the container by itself. You don't need a complete operating system to be able to run an application. All you need is an application environment, isn't it?
Yeah. That's how the app engines are working, right? Amazon, Google.
Very similar to that. Very similar to that. See, in general, our application, multiple applications running in machines, self-contained applications. Think of it like that way. Okay. Now, the idea is that when you see the picture, I wanted you to possibly think of containers. Rashi came up with that. So, container is a word apart from your standardization, optimization, and everything else. So, container is very a critical point. So, what we have is that multiple individual containers are put in a single container. So, we consolidate things, we optimize the resource, and these containers are very clearly separated, so they coexist. Okay, so that's the keyword that I was expecting. That is very important for you to understand at a later point in time to how well we optimize and utilize resources. Okay, shall we move on to the next one? So, yeah, we have had enough kitchens and cars and everything else. So let's quickly run through some technical slides now. And what we actually have is that we have multiple individual containers or multiple individual hardware pieces which have their own operating system plus applications. And post surgery, they become one single hardware. We have multiple what we call as guest operating systems. So the hardware will have a hypervisor layer. Okay. Do you know from where this word hypervisor comes? Operating system is called a supervisor. Okay. So a layer that sits on top of the operating system, or a layer that supersedes the operating system, layer that can control and supervise the operating system, the layer that can supervise the supervisor becomes the hypervisor. Anything on top of super is hyper, right? So that is why the word hypervisor comes in. So hypervisor is responsible for anything that runs on top of the hardware part. So remember, in the traditional way of or a non-theoretical way to look at cloud computing is also a management layer on top of a virtualized infrastructure. But theoretically, it is not necessary to have virtualization to have cloud. We'll discuss more on that as we move on. Okay, you can actually have physical servers and physical components provisioned to cloud. But just to have an understanding, hypervisor is the most critical layer here, and that is, as one of you said, is a software layer that provisions hardware and storage and whatnot on top of it. Okay, so you have a physical resource, you have a hypervisor layer that abstracts that physical resource to start with. Okay, we are taking a server virtualization example here, but the same for desktop virtualization, network virtualization, or storage virtualization as well. Okay, there is no major difference from there. So you have a hypervisor layer that abstracts these. It standardizes any hardware or any operating system that runs on top of it. It consolidates and optimizes the resource utilization on top of it. And individually, what it creates is that it creates multiple containers that share one single large container. Okay, is that clear? Okay, fine. So that is where Atul generally through the hypervisor you do this orchestration. So this is the guy who actually does manage the whole music show. He says you guys move here, this and that. But if you look at it in a cloud environment or a slightly complex virtual environment, it is not the hypervisor that orchestrates. Hypervisor is a musician, and you have a centralized management system that orchestrates even the hypervisor. If you look at from a VMware perspective, your VMware vCenter kind of a component will have the orchestrator, which will move the virtual machines in and around. Which will tell that this is what should be doing at a given point in time. You understand the orchestration now, Atul? Okay. Yeah. So hope all of you understand what we are discussing.
Yes.
Okay. So let me just move to the next one here. So this is how it looks. You have individual containers with individual servers or desktops or whatnot with operating systems and application on top of it. And post virtualization, you have a new layer introduced in here, which is a hypervisor layer. You look at there's a green layer here in which multiple application operating systems are put in. Now this is an important component that you can understand is that post virtualization, one of the major takeaways for us is that you have a layer that separates application from and operating system combination from the underlying hardware. It's very clearly separated, right? So there's a hardware component that is separated and all things logical on top of it is separated. Do you understand? So the application and operating system are now independent of the hardware that you have. Is it clear?
Yes, sir. So here, are you saying like, okay, and we have a hardware that is separate, then we have operating system that is separate, and then application separate. So you combine whatever you want together and make
The application is not actually separate. Firstly, application is not separate as in the picture as of now. So Atul said, application virtualization is the one that makes application separate. Okay. So let me ask you a very simple question. You said you have a Windows operating system in your 8 GB laptop, isn't it?
Yeah, right. Yeah.
Now, can you actually, can you separate your Windows operating system from the hardware?
No.
Now you can copy it, you can create a copy, you can replicate it and do everything. But can you actually take it out of the hard disk that you have? You cannot. At the best, you can wipe it.
Yeah, unless like I format it.
It's closely, when you format it, it's lost. It's not separated.
Yeah, right.
Okay, so the point is that it is running so close, or it is very tightly coupled with the hardware, isn't it?
Yeah, you're right.
In a virtualized system, in a virtualized environment, the operating system runs independent of the underlying physical hardware. That primarily means you can take the operating system and put it on another hypervisor, it will run.
Oh, okay, I got you.
It's a file. End of the day, a virtual machine is nothing but a set of files.
Okay.
So like you can carry files on different machines, between different machines you can migrate and do stuff. You can carry an operating system. Similarly, can you separate your application from this? You have a, say, PowerPoint application, okay? You have a Microsoft Office installed in your machine. Can you separate the application from the operating system?
Yeah, it depends on the application. For example, if it is, I would say like Java-based application like Eclipse, it's just a copying and like you can just copy it into some other operating system and it would work fine.
You can copy it, but can you separate a typical application that you do next and click? Actually,
yeah, no, you can. It has to work within an operating system, right?
It has to work within an operating system. That's the word, right? It doesn't run on the operating system. That means you have, you would have used Putty, right? Right? Putty, does it get installed? No, it's a portable application.
No, it doesn't get installed, yeah.
You can actually run inside, with an USB, isn't it?
Yeah.
You can put it in USB and run. It doesn't get inside the operating system. You can separate it. Application virtualization is a way to separate operating system with application.
Oh, okay.
It is to abstract operating system from the application, which is not under current scope for us right now. So we will discuss about it more at a later point in time. Okay. So the point that we are trying to create right now is that the application and operating system, which is logical in nature, is separated from the physical component. That's where the key abstraction lies. There is a hiding. The underlying physical hardware is hidden to the application and operating system combination. And this hiding happens through the hypervisor. That is very, very important. That's the abstraction that you are talking about. Okay. So you create logical spaces on top of which the application operating system runs. And as I said, that gives you the ability to move around the application operating system component, or as we call it, it's an appliance. When we actually move into the cloud space, this ability has a direct impact on how soon or how fast you can provision and deprovision resources. Okay.